In this lesson, we want to be able to say that I can evaluate functions. Let's remind ourselves of what a function is. A function is a relation in which each element of the domain is paired with exactly one element in the range. This means that for every input we have exactly one output. We are used to seeing equations as the equation notation, as y is equal to 7x minus by 8, or y is equal to negative 1 over 5, x plus 2. In fact, this is our slope-intercept form, which we will talk about more in another video. There is function notation that we need to talk about. In function notation, we notate it with typically an f and put parentheses with x inside. This is not saying f times x, this is saying f of x. I know the word of typically gets associated with multiplication, but we are dealing with function notation where it is f of x, meaning the x is being placed inside of the function. So function notation of this is going to equal f of x is equal to 7x minus by 8. So in other words, what we're doing is we're taking this function and having it replace the value of y. Everything else is exactly the same. We just are substituting the value of y for f of x. Function notation is the same as equation notation, except for we put the function instead of y. F of x equals to the y value. It doesn't have to be f of x. We could use h of x if we want. We can use g of x. Main thing is we need to be able to recognize when we are using function notation and when we are not. So this one could be h of x equals to negative 1 over 5, x plus 2. By the way, this would be the same thing as saying h of x is replacing the value of y. It's substituting. We're taking the value of. So let's actually get into the fun part. In this example, we have the function f of x is equal to negative 3x minus by 2. Let's find the value for f with 1 inside instead of x. So basically what this is saying is that we are taking the value of x and replacing it with 1. We're taking it and substituting to evaluate this. So f of 1 equals to negative 3 times by 1 minus by 2. Negative 3 times by 1 is negative 3, minus by 2 gives us negative 5. So by evaluating this function f of 1, we end up with our y value with our output being negative 5. So input was 1. We input the value of 1 into our equation, into our expression, to be able to get our output being negative 1. With part B, we're doing the same thing, except for we are inputting negative 5. We're taking the x value and replacing it with negative 5. Then we are taking this negative 3 and minusing that on the outside. So in other words, what we're going to have is this is going to be the same thing as negative 3 times by negative 5 minus by 2. This is our function, f of negative 5. Then we take that and subtract it by 3 because we have our function, and we're minusing stuff outside of that. So this would give us the grand total of negative 3 times the negative 5 is positive 15 minus by 2 minus by 3. So this would give us positive 15 minus by 2 is 13 minus by 3 gives us 10. So the value of f of negative 5, take that subtracted by 3, gives us an output being 10. Let's look at another example of this. Instead of f of x, we have h of t. This is our function where h of t is equal to 3x minus by 2. Let's find the value of h of 0 minus by h of 2. So what we're going to do is we need to find h of 0. h of 0 is going to be 3 times 0 minus by 2. Let's go ahead and just put that in parentheses. And then we have subtracted by h of 2. So we have 3 times 2 minus by 2. Now let's go ahead and evaluate. PEMDAS, order of operations. We work with our parentheses first. The multiplications inside those. 3 times 0 is 0. So we have 0 minus by 2 minus by 6 minus by 2. Just simplifying it down. This would give us a negative 2 minus by 6 minus by 2 gives us 4. Negative 2 minus by 4 is going to give us a grand total of negative 6. So evaluating h of 0 minus by h of 2 gives us the grand total of negative 6. Part B of this, we have a lot going on. We have 2 on the outside multiplying h of negative 3. that's inside. Then we want to add 7 on top of this. So what we're going to do is we're going to take this, put 2 on the outside. We're going to get some parentheses. We're going to use some brackets on this. Let's do h of negative 3. H of negative 3 will give us 3 times, replace your t with your negative 3, minus by 2. That is your function. Remember, this is our h of negative 3. Right? H of t is 3 times t minus by 2. Replace that value. Then we are going to add 7 outside of that. Okay, well now let's go ahead and just evaluate this. Work inside the parentheses first. So we have 2 times, this would be negative 9 minus by 2, plus 7, which gives us 2 times negative 11 plus 7. 2 times negative 11 is negative 22 plus 7. And that's going to give us negative 15. In this next example, we have g of y. This is our new function that we're going to be dealing with. G of y equals to 2 times y squared plus 3y minus by 1. Let's find the value of g of negative 2. So this one is actually a lot more simple than what we've been doing. Remember, this is saying that we put negative 2 as our input and see what our output is. So anywhere we see a y value, replace it with negative 2. So we have 2 times, that would be negative 2 squared, plus 3 times, this would be negative 2 minus by 1. It's always a good idea to put parentheses around what you're substituting. That way you remember, oh, I'm not subtracting 2 minus by 2. It's actually a multiplication, and it is, the whole thing is being squared. So it's always a good idea to put parentheses. So, order of operations. Let's start with the exponents. We have 2 times negative 2 squared is positive 4. Then we have plus 3 times negative 2 minus by 1. Keep on going with this. This will be 8 minus by 6 minus by 1. Then this will be 8 minus by 6 gives us 2, minus by 1 gives us 1. So evaluating g of negative 2 gives us the output being 1. Remember, that would be an element in our range. The input is our domain, being negative 2. The output would be part of the range, which is positive 1. With part B, we're going to do the same thing. We're going to have g of 0 that we're going to be evaluating, and also g of 1. What we're going to do is we're going to put this 5 on the outside. We're going to get some parentheses. We're going to put brackets. And we're going to put g of 0 inside. G of 0. Anywhere we see the y value, let's replace it with 0. So this will be 2 times 0 squared plus 3 times 0 minus by 1. So let's put 0 in those spots. Close the brackets. And this will be plus. Let's go ahead and put parentheses around here as well. This would be 2 times 1 squared plus 3 times 1 minus by 1. That's quite a bit to deal with. So let's just break it apart. So we have this 5, deal with inside the parentheses first. 0 squared is 0 times 2 is still 0. So this all right here is 0. 0 minus by 1 is negative 1. Okay, that's simplified down nicely. Plus 1 squared is 1. Times by 2 gives us 2. 3 times 1 is 3. So we then have 2 plus 3 minus by 1. This is going to give us negative 5 plus 2 plus 3 is 5, minus by 1 gives us 4. So negative 5 plus 4, which gives us negative 1. So the output of this, all that mess of the function, is negative 1.